Hello everyone. In this video, we're going to talk about the power rule. So suppose an exponential expression is raised to some power. Now we can simplify the result. Now to do this, we use the power rule of exponent. Now let's consider the expression x exponent 2. That's in bracket, then that expression is raised to the power 3. Right. Now, the expression inside the parentheses is multiplied twice because it has an exponent of 2. Then the result is just multiplied 3 times because the entire expression has an exponent of 3. Now, this means that this expression here has 3 factors, which is x squared dot s squared dot s squared. Right? So with this one have 2 factors, which is x dot x. This one too has 2 factors, which is x dot x. This one also has 2 factors, which is x dot x. Right? So when we are done, we can just add all of them together or multiply all of them together, which is x dot x dot x dot x dot x dot x. Now when we add all of them, 1 2 3 4 5 6, we have x exponent 6. Right? Now the exponent of the answer is the product of the exponent, which is x exponent 2 in the bracket raised to the power 3, which is x 2 dot 3, which is equal to x exponent 6. So in other words, we are raising an exponential expression to a power. We can just write the result with the common base and the product of the exponent, which is if we have the expression a in a bracket, and the a in the bracket is raising to the power, let's say m, and in the bracket raise the power n. Now we can simplify this as a to the power m dot n. So we need to be careful to distinguish between the uses of the product rule and the power rule. Now when using the product rule, different terms with different bases are raised to the exponent. Now in this case, you have to add the exponent. Now when using the power rule, a term in an exponential notation is raised to a power. Now in this case, you have to multiply the exponent. That is the difference, right? Now let's compare them. Now let's say here we have a product rule in this side, and here I have the power rule on this side, right? So with this one, let's say we have 5.3.54, and this one should be equal to 5.3 plus 4, right? Which is equal to 5.7. But under the power rule, if you have 5.3 then 4 here, with this one we should get 5.3.4, which is 5.12. You can see the difference here. With the product rule, we added the exponent, but with the with the product rule we added the exponent, and with the power rule we just multiply the exponent. So that is the difference. You can see the difference there. So now let's look at we can look at another example. Let's say we have maybe x exponent 5 dot x exponent 2. So with the product rule, how do we do this? We have x adding the power, which is 5 plus 2, then we get x exponent 7, right? So with the power rule, how do we do that? So with the power rule, we are going to have something like x exponent 5 in the bracket, and that raised the power 2. So with this one, we have x 5.2, which is x exponent 10, right? So very simple. So you can know the differences between the product rule and the power rule. They have different meanings. So let's look at the power rule. So for any real number a and a positive integers m and n, the power rule of the exponent states that if you have a exponent m in the bracket, which the bracket raised the power n, then a is equal to m, or a raised the power m dot n. That's what we have. Now let's look at some examples, real examples. So let's write each of the following products with single base. So let's look at it. So the first one, we have x in the bracket exponent 2, the bracket exponent 7. So how do we do this? So we have x 2.7. That's multiplication. So we have x exponent 14, right? Very simple. You can pause the video and try to do the b and the c on yourself. So let's look at the b. So with the b, we have 2t in a small bracket raised the power 5, and a big bracket raised the power 3. So how do we do that? So this 2t, right? 5.3. So which will be 2t in the bracket 15, right? Now let's look at the c here. So with the c2, we have in the small bracket we have negative 3 exponent 5, then big bracket raised the power 11. So with this one too, we have negative 3, right? Negative 3 raised the power 5.11, which is negative 3 exponent 55. Very simple. Very, very simple. Now let's look at zero exponent rule. The zero exponent rule. Okay, so let me count this one. So the zero exponent rule. So returning to the quotient rule, we made the condition that m is always greater than n, so that the difference between the difference, which is m minus n, will never be 0 or negative. So what will happen if m is equal to n? Now in this case, we will, so if in case we have maybe m equal to n, what will happen? Now in this case, we will use the zero exponent rule of exponent to simplify the expression to 1. Now to see how this is done, let's begin with this example. So let's say we have t exponent 8 on t exponent 8. So you can see that t exponent 8, t exponent 8 will cancel each other, then we have 1. Now if we were to simplify the original expression using the quotient rule, we will have something like, so with this one, we will have something like t exponent 8 on t exponent 8 will be t exponent t exponent 8 minus 8, right? Then we have t exponent 0, right? Now, if we equate the two answers, the result is t exponent 0 is 1. Now, this is true for any zero real number or any variable representing a real number. So the sole exception in the expression, which is 0 exponent 0. Now, this appears later in more advanced courses, but for now, we will consider value to be undefined. So now let's state the zero rule. So for any non-zero real number a, the zero exponent rule of exponent states that a exponent 0 is equal to 1. Very simple. Let's look at some real examples. Now we're going to simplify each of the expressions using the zero exponent rule of exponents. Now the first one, we have a, we have 3 c exponent 3 on c exponent 3. So with this one, you just have c being 1, then exponent 3 minus 3, then we have c0, which is equal to 1. Very simple. Now let's look at the b. You can pause the video and try to do this on your own. So with the b, we will have negative 3 dot x 5 on x5. Then we will have negative 3 dot x exponent 5 minus 5. Then we have negative 3 dot x exponent 0, which the x exponent 0 is 1. So we will have negative 3 dot 1. Then the answer is negative 3. Very simple. Let's look at our last question. So with this one, our last but one. So with this one, we have j squared k, all in bracket raised to the power 4. The down part, we have j squared k dot j squared k all exponent 3. How do we do this? So first, let's use the product rule in the denominator. So with this one, we'll have j squared k exponent 4 on j squared k, right? Then 1 plus 3. Then when we do, we should get j squared k exponent 4 on j squared k exponent 4. Now we have 4, 4. So here we can have j squared k 4 minus 4. Then we should have j squared k, which is 0, then 1. You can see how we did it. Now let's look at our last example here. So with this one too, we have 5 multiplying rs squared in the bracket squared. Then we have the down part rs squared in the bracket squared. So with this one, we just write 5 open bracket rs squared, then with the exponent 2 minus 2. Then we have 5 multiplying rs squared 0. So with this, we have 1. So that'll be 5 dot 1. Then our answer is 5. Very simple. And this is the end of this video. See you in my next video. Thanks for watching. Bye.